Consider the following experiment. I take a length 10 vector of random integers from 1 to 30. Then I go through and I delete every integer that appears more than once in that vector. And then I ask, how long is this new vector where I've deleted all the duplicate entries? Okay, that's going to be one experiment, and I want to compute what's the expected value of this experiment. So it's difficult enough that I'm going to break it up into two pieces, one piece for the experiment and one piece for the expected value. So let me call this delete underscore dupes for delete duplicates. And I don't need to have an input. Maybe later if I wanted to change those numbers, length 10 and integers 1 to 30, then maybe the 10 and the 30 would be inputs to this, but I don't need it to be. And so I'm going to say L, that's going to be the length after I've deleted the duplicates. So first I need to make the original vector, the length 10 vector of integers 1 to 30. So let me say V is rand I, and it's supposed to be integers 1 to 30. So I do 30, and then length 10. Remember, you can't just do 10. If you did just 30, 10, that would be a 10 by 10 matrix. I want a 1 by 10 matrix, so that's why I do 1, 10. And then the hard part is deleting the duplicates. So how do I do that? Well, I'm going to do it what I think is the easiest way, but it would be good for you to think about what's a faster way to do this. So I'm just going to go through every integer, 1 to 30, and see if it appears. And each time I get one that appears, then that's a new entry that's going to be in our delete duplicate vector. So for example, let me say t equals 0. That's going to be the total number of integers that appear. And then for I equals 1 to 30. So I go through 1, 2, 3, all the way up to 30, and I ask, does that appear in the vector? And for each one that does, that's one that I add to the total. So if, and how do I decide if the number I appears in V? Well, the easiest way is to ask any V equals I. Okay, and if it does, then I add 1 to T. And so I guess it would have made more sense to have the output be called T, so I changed it from an L to a T. And now that's the output. So there's my delete duplicates. So let's test it. And I don't need any inputs for this. And just as a reality check, the number of distinct integers that appear should be somewhere from 1 to 10. Okay, there's 9, there's 10, there's 10, there's 6. And then the overall thing that I want is I want to know what's the expected value. Okay, that's just a fancy way of saying what's the average of this number. So that one I can do also in a function. Okay, so let me call it find EV for find expected value. And this one I will have an input, and is going to stand for how many times I run the experiment. And then let's call it E for expected value. And so what should I do here? Let's have T for total again. T is 0. And I want to do something for each of the experiments. So for I from 1 to n. So for each of these experiments, I want to run this delete dupes function. Okay, this function here. I'm going to close it so it doesn't keep coming up. So for each of my experiments, I add to the total the outcome of delete dupes. So that's the total, that's the sum. I've added up all these different outcomes. So for example, here I would have added up 9 plus 10 plus 10 plus 6. And now for the expected value, it's the total divided by the number of experiments. So t divided by n. Okay, I save it. And now let's test it out. So find underscore EV of, how about 5? So that's do it 5 times. 8.8. Okay, that makes sense as an expected value. Okay, that seems like it makes sense as an average of this 9, 10, 10, 6. But to make it more accurate, we should definitely use bigger numbers. Like, let's do 100. Okay, 8.64. And let's try to keep increasing the number until the first 2 digits look like they're steady. So let's go to 1,000. Let's go to 10,000. Okay, so it looks like the 8.6 is steady. Let's go to 100,000. Yep, so somewhere around 8.6. And if we find some way to run delete dupes in a more efficient way, then we'll be able to input even bigger numbers. So we'll be able to run even larger numbers of experiments and get a more accurate expected value. But 8.6, that should definitely be the first 2 decimal digits of the expected value of this delete dupes experiment.